Hello, everyone. Welcome to the Carolina Weather Group. This is the Wednesday, March 22nd edition of the Carolina Weather Group. Fourth week into the month as we continue the National Weather Podcast Month. For all those who are joining us, we appreciate you following. And for our loyal followers, we appreciate you as well. Tonight we have Doug Marcy on. We're going to talk about coastal water rise and the effects of that, and a very important topic tonight. So very happy to have Doug on with us. Doug has a whole presentation planned out for us, so looking forward to that. Before we get that, let's do a few housekeeping rules. If you have any questions during this event, feel free to send them to us via Twitter or our Facebook page. We really hope it's Twitter because our Facebook page is having some issues right now. So send them to us on Twitter at Carolina WX Group. That way we are sure to see them. But if you want to send them on Facebook, hopefully they'll come through and we'll monitor that as well throughout the show. Again, if you're listening on the podcast, we'll have Doug share his information towards the end of the show. And if you have any questions for him, you can direct those as well. So that's about it. We have a lot of exciting news going on, so we'll keep this part short and sweet. I did want to show you what's going on in Western North Carolina. It seems like we cannot get rid of the wildfire threats. And that's plagued again. This is from my Twitter page earlier today. Can you guys see the picture?
Yep.
Okay, so I'm going to show you a few pictures. This was around maybe 2 o'clock today. This is the White Creek fire up in the Linville Gorge. I know if you live in, excuse me, Western North Carolina, you've probably heard about it. If not, another forest fire in the mountains. And then I want to show you, this is about 5 o'clock, 6 o'clock tonight. A lot of intensification due to the fire spreading, but also some backbuilding with the fire fighters up there as well. So as you can see, smoke-filled air throughout the foothills, also showing up on radar. So the fire pretty intense, as you can see. And this is just another view from McDowell County, kind of on the backside of the fire. So that's what we're dealing with here in Western North Carolina. With the storm system that moved through last evening, we here in the foothills didn't get a lot of rain, not as much as they did in the upstate and the Piedmont areas, only 5/100ths of an inch, so no rain to really help the fire efforts at all. So we need some rain, and unfortunately it doesn't look like a lot is coming our way. So that's what's going on here in the Western Carolinas. Dry, we had some wildfires. All the storms and stuff was down in the Charlotte area. So I'm going to switch it over to James, who can tell us a little bit about the storms that rolled through there last night, and maybe even what happened in parts of the upstate. James is muted. We cannot hear James. All right, let's go up to David Reese in Charlottesville. David, how's the weather up there in Virginia? You kind of missed out on the storms last night, didn't you?
We did. It's a little chilly right now. Our high temperature today was 58 degrees, which we hit at about 101 this morning. We've been in a free fall ever since, and we officially rebounded back to about 51, 52 degrees in the middle of the afternoon when many of us were able to experience it. And now we're already back down. Oh, what's the current temperature out there? We're already down to 45 degrees. The low so far today was 44 at 7 a.m. So going to beat that here in a few minutes, a few hours for sure. Next couple days, sunny tomorrow, cold, highs near 50. Over the weekend, though, we're looking at a nice ridge of high pressure building in and pumping warmth our way, mid-70s in the forecast on Saturday. Rain possible on Sunday and Tuesday. But other than that, it's been somewhat uneventful. Saturday was a little interesting with the upper low moving on through. We had a few reports of small hail around central Virginia from some of the stronger thunderstorms. Actually was able to get out and enjoy some of the thunderstorms as I wasn't working, and I was like, spring is here. Now if we can just get rid of this cold weather with a low tonight about 24, 25 degrees. So still cold, but warmth is on the way.
Scotty is now muted.
No, I'm good. I'm good. So,
Good.
Shay, if you don't mind, it says I'm presenting to everyone. I don't think everyone wants to see my ugly mug. So.
You're right. I got you covered.
Thank you. I appreciate that. Let's go down to Charlotte, North Carolina now, where I think James may have fixed the technical issues.
Hello, Mom. Can you hear me now? All
You're
right.
good.
Excellent. It's the night for technical gaffes because tonight was the night we wanted to debut Facebook Live to you, and Facebook's not working, but I don't think that's on us. If you can post to a Facebook page, do let us know. But yeah, so we got quite some storms yesterday. Nice second day to spring to kick things off. It got quite warm, mid and upper 80s. Our friend Kit, who I don't think is on the show tonight, so I will show off the pictures that he showed off on local TV here yesterday. Take a look at some of that hail. Mainly the mid-center of Charlotte and the north side of Charlotte got hail up to about 2 inches yesterday, but it wasn't just the Carolinas. As a matter of fact, Charlotte was kind of really just the eastern edge of where these storms rolled through. South Carolina got a pretty good light show, as did parts of Athens, Georgia, the Atlanta area, and I had a video queued up, and YouTube has gone rogue on me, so let me roll it on back. It is the Sky Cam from the University of Georgia. When we had Marshall Shepard on a few weeks or months back, he talked about it, and that's Wake Forest. So I don't know what's going on here, but it was a great look from 2 different vantage points at the university there. Here it is. As it plays through the yesterday, you can see in the bottom of the screen, you can watch the temperature climb up to almost 90 degrees. I think it's going to top out at about 87 degrees on the left side. State Botanical Gardens, just south of Athens, right side, mid-campus, the Climatology Research Lab. And here we go. As we roll into the afternoon hours, you can see the increasing clouds. And then just as those temperatures peak and then drop off as the skies open up, lots of rain, lots of lightning and thunder came rolling through the greater Atlanta area yesterday. And I just thought that was a really cool vantage point to share.
That is pretty neat. I like that. Pretty neat. Yeah,
and it really wants to go to FSU. David, what did you do to my computer?
David's tapped into us. So let's go up to Peter, who's up in Jersey area. Peter, the talk was before the show is the Cinnabon that you're eating. So tell us how it was.
This free plug to Cinnabon, everybody. Here you go.
Hey, they can sponsor us if they want to.
Hey, I would love them to. Give us free Cinnabon. Look at that pecan. Oh, man, I'm in my glory tonight. But anyway, enough about that. It's been pretty chilly around here, below average most of this week. We've been in the 40s and 50s. And tonight we're actually going to be down into the teens. So when you get up tomorrow, it's not going to be very pretty heading out to work. But that's the story of my life up here. And we're going to heat up a bit on Saturday to maybe 70, and then back down to the 40s again for Sunday and 50s next week. So it's kind of up and down through the next week or so. And no snow. So that makes it even better. Very happy.
Can't the weather just make its mind up? I'm ready for it to stay warm. I'm telling you. Just ready for the warm.
I hear you.
Well, let's go over to Mr. Ricky Matthews, who was in East Tennessee. Ricky had a very exciting week representing the Carolina Weather Group, and has some exciting news about the Carolina Weather Group. So let's let Ricky give us all the details of what's been going on over the past couple of days.
Yeah, we had the great opportunity to, as part of National Weather Podcast Month, Scotty, to join Weather Brains last Monday. We had a great panel of guests. We had Gary from the Weather Service, or retired Weather Service now, up in Mount Holly, New Jersey. We had Gina Esco from the D.C. area, one of the social scientists. And, of course, Chuck Doswell, always a great person to have on Weather Brains, and, of course, the regular cast there. So it was a good conversation about the snowstorm that happened up in the Northeast in some spots and didn't happen so much in other spots, and kind of the uncertainty behind that, and how it was communicated and how we can maybe improve that. Some good points brought up, some points that may be a little hard to implement, but, discussion's never a bad thing. So really enjoyed our time as part of that. And thanks to Bill Murray for inviting us on that. So you mentioned we had some exciting news. We do want to share that the Carolina Weather Group accepted Rick Smith's request for all the podcasts associated with National Weather Podcast Month to become Weather Ready Nation ambassadors. And we put in our paperwork a few days ago and got our email yesterday that we were accepted as a Weather Ready Nation ambassador. So we're excited to be part of that program that helps promote weather safety across the nation as part of our podcast and some of our outreach efforts.
Yeah, looking forward to that. Looking forward to having those guys. Maybe we can have those guys on and really let everyone know what the Weather Ready Nation's all about. So let's toss to Shay, who is going to kind of tell us what's going on in the Charleston area and then bring in our guests tonight. So, Shay, the floor is yours, my friend.
Fantastic. So yeah, we had some thunderstorms last night here at the coastline too. I guess, can everybody see the screen that I have here? Okay.
Yep.
So quarter size hail in the Charleston area. This is just inland in North Charleston. Is rather rare. I mean, we usually get pea-sized to dime-sized hail if we get that at all. But I was sort of, we talked last night about the mesolow that developed sliding downslope from the Appalachian Mountains. And, the last several cold fronts, probably a dozen, that have moved through the area have been sort of thwarted by the cool shelf waters, which are about 58 degrees. Now they're up to about 60. I was sort of banking on that last night to sort of stave off the thunderstorms, but we found that the mesolow is a much stronger system that has much more convective activity associated with it that the shelf waters are not able to thwart. So we got quarter-size hail just inland. I mean, I saw some of the pictures of 3-inch to baseball-size hail upstate. I couldn't believe it. That's just not normal for the Southeast. But we did rebound after the thunderstorms last night, and we had a really nice, beautiful spring day, about 76 degrees at 2:56 p.m. And we are going to cool down tonight. We're going to get into the upper 40s, and we'll probably only get up to about the mid 50s tomorrow. We're sitting with a northeast wedge along the coastline, and so those winds are going to kick up anywhere from about 17 to 21 knots, or even higher in gusts for pretty much most of the day until the afternoon when they sort of fade out. So we got a little bit of a cool down, and we're going to have a nice gradual warm back up as high pressure moves out into the Atlantic, and sort of brings another southerly flow back into the coastline. So it'll be kind of gradual over the several days. We'll probably have a stronger sea breeze by Sunday. So that's the weather for Charleston right now. I guess if everybody's finished with the regions, we'll go ahead and introduce Doug Marcy. He's with us tonight from NOAA. He's the coastal hazard specialist for NOAA. He works with Digital Coast. He works with flood inundation maps, GIS, you name it. He is an expert in his field, and he's here to talk about sea level rise with us this evening. So I'll hand it to you, Doug. We really like to introduce our guest and ask, how did you get to where you are now with what you do with NOAA?
Oh, thanks, Shay. Can you hear me okay?
Yes.
Okay, good. Yeah, I started with NOAA I've been with NOAA about 15 years now. About 2002 is when I started. Before that, I worked for the Corps of Engineers here in Charleston as a hydraulic engineer. I worked on a lot of hydrologic modeling and coastal engineering projects. And then before that, I worked at the South Carolina Coastal Management Program for a couple of years, helping them out as a NOAA fellow, working on some GIS applications. But since I've been at NOAA, I've been working a lot on various types of flooding issues, starting out working actually with the Weather Service on a lot of the inland flooding, river flooding stuff after Hurricane Floyd, 1999, kind of dates me a little bit. And then more recently on storm surge issues, we work a lot with our Hurricane Center storm surge unit down there, Jamie Rome, and a lot of their products that they're putting out. And we've been doing a lot of sea level rise work, a lot of mapping work, which is what I'm going to kind of talk about today. So enough about me. I'll go ahead and get started. I do have quite a few kind of visuals. I'm going to share my screen here. And can you see?
Yes, you are up and running.
Okay. Good deal. Okay, so yeah, title of the slide of the talk is really talking about one of the main impacts we're seeing, especially here in the Low Country, South Carolina, but a lot along the East Coast, is the main impact we're seeing in climate change, and the most real kind of in our lifetime impact is sea level rise. So we'll talk a little bit about that. We're going to start out kind of at the global scale, talk about some of the drivers that are causing this, what causes sea level rise globally, and then drill down into what's going on locally, regionally, and then locally, and then talk a little bit about projections, where we're going in the future, some of the new science that's coming out there, and then what local communities like Charleston, where I'm from, and Shay's from, are doing about it in terms of starting to deal with a strategy and actually investing real dollars into some of the mitigation for that. So you guys are all meteorologists, you understand basic physics, and my background's in geology, so I'll try to put a little bit of historical perspective on this too as we go through, but it's pretty simple. This graph here is out of the National Climate Assessment, the third National Climate Assessment. As you know, the fourth climate assessment is going on right now. We hope that's going to be coming out in 2018, which will kind of be an update of the science. But basically, you got two things here going on. CO2 concentration increases in the atmosphere that basically acts as a blanket and causes the the global temperature to increase. We've gone above 4,000 parts per million. 400 parts per million now with CO2 is highest it's ever been, like 600 million years. So temperatures following that, and we think eventually sea level rise will as well. There's a little bit of a lag because the ocean does tend to absorb some of the heat initially, but it will catch up. Also stole this out of the National Climate Assessment, just looking at how we know the world is getting warmer. All these indicators, we have more water vapor. If we have higher temperatures, obviously more evaporation, more water vapor, so we may have more intense precipitation events. We've certainly seen that, like Louisiana here in South Carolina, 2015, and Matthew up in North Carolina. These are just amazing rain pulses, and atmospheric rivers that are tending to be more, starting to be more common. Sea surface temperatures going up. All these things are going up, but at the same time, you got sea ice depleting, especially in the Arctic, and glaciers, ice sheets, snow cover going down, and of course, sea levels going up. But this has happened before. And, you know, as a geologist, that you go back and look at the geologic record, you know, before man was even here, before we discussed about, well, is man causing global warming and all this? I mean, the Earth cools and warms on cycles about every 150,000 years. If you look at this, goes back 400,000 years ago. We have these ups and downs in sea level. If you study geomorphology, especially, you know, where the fall line is on the East Coast, that's kind of the upper limit of where sea level was about 5 million years ago. And then during the last ice age, the glaciers came down as far as Long Island, and then the ocean was about 65 miles off the coast than it is today, about 20,000 years ago. So you see that it's gone up and down quite a bit. And then in the last ice age, it went up pretty fast. About 22,000 years ago was the last glacial maximum. You can see we had this pretty intense meltwater pulse, and sea level rose pretty rapidly on geologic time scale. But then about 6,000 years ago, we kind of stopped. We kind of leveled off. And unfortunately, this is where civilization and humans started developing along the coast, of course, because of the coastal resources, the fishing and everything else, and the commerce. We built cities right along the coast, and sea level has been pretty much static since humans have been around. And so we kind of have this mental model that sea level is always going to be where it is now, or was, and unfortunately, it's starting to change. We're looking at globally through tide records throughout the world, and also now using satellite altimetry since 1993. We're starting to see this upward trend happen once again. And in a time when we shouldn't be seeing the cycle, and we think that's because the CO2 concentration is partially being driven by human activity, because normally we wouldn't see that until a little later on. And we already talked about the warming world, but what causes sea level to actually change? There's a lot of factors. The main ones right now that are driving the sea level change globally is the increase in the ocean temperature causes the ocean to expand. It's a simple physics kind of thing. You fill a glass full of water, and you stick it in the microwave, and you turn the microwave on, and it boils over. So the water expands and spills out of the cup. So there's no other place for the water to go, so it fills up the basin and starts to increase the water levels. And then, of course, we have the contribution of ice over land. Sea ice is not going to cause a problem. It's already floating. It's the ice over land that once that starts to break off and displace water, but also melt, that's going to increase sea level. And then, of course, you have these other contributing factors. Locally, what's going on with subsidence it becomes very important in places like Louisiana. Also, here on the East Coast, we have some hot spots with some subsidence that increase sea level locally. Just looking back since 1993, you can see what we've seen so far with this global trend. What's adding to that is the thermal expansion component plus the added meltwater is giving us this what we're seeing in the increase. A little bit about what NOAA does. We, as you're aware of, if you live on the coast and you do coastal meteorology, you probably look at especially for water levels, you look at our NOAA tide gauge data, or Seaman stations, or things like that. This is an example of a tide station. You can see, and here is there's a little stilling well. This pressure sensor measures the pressure difference in the water levels. We also use microwave microwave radiation to as another way of doing that too. Basically looks down and captures the water surface. That actually gives us some pretty cool data too, because we can start to see wave effects as well. The whole point of these older systems is to dampen out the waves and just record the water level, and then it sends it through a satellite altimetry, and it gets absorbed into the data stream that goes to the weather forecast offices and others. I think it's called HADS. So we monitor it locally, but we also monitor it globally using satellites. So the satellites, the polar orbiting satellites, cover the entire Earth over a period of time. They measure the sea surface, and that gets averaged over time, and that's what's been used in addition to the in situ measurements. And so with that data, we can start to look what's going on globally and then nationally. And we can see, this is a great site that our sister office, COOPS, has the tides and currents, sea level rise trends. You can see where we have areas of hot spots. Louisiana coast, sea levels trending a lot higher on the East Coast, but you do have places in the northern parts of the northern hemisphere where sea level is going down relative to the land because it's still rising. The land is rising because the lack of ice on there now. Because post glaciation, the crust tends to rebound as the weight is lifted from the ice sheets. So what's going to happen in the future? Again, pulling from the National Climate Assessment, we have these different kind of relative concentration pathways, they call them RCPs, and these are kind of greenhouse gas scenarios. Everywhere from business as usual, which is RCP 8.5. In other words, we're going to keep on producing as much CO2 as we are now into the future. And that's the red line there. And then you have your kind of your best case scenarios. If we level out, Paris Agreement and all that comes to fruition, then we can kind of keep things around the 2-degree range. If by 2100 you're on the red path, you could be up to the 8 degrees increase range. And that's kind of, that data there drives some of the models that we see for sea level rise. For the third National Climate Assessment, there was a subgroup there that kind of looked through all the literature that was out there on different sea level rise rates, including the IPCC, and kind of did a expert solicitation of the literature and kind of came up with these scenarios that were used as input. We call these consensus scenarios. Sometimes they're called the NOAA scenarios, but they came out. It was a Paris et al. So Adam Paris was a colleague of mine that was at NOAA at the time. He's left now, but it was the lead on that. It was a multi-agency and nonprofit universities and NGOs. And essentially we looked at 4 different scenarios. One is just a simple extrapolation of the current trend. One includes ocean warming, just ocean warming. That's the intermediate low. A moderate ice melt scenario, and then a major ice melt scenario. So that's ranged from about 0.2 meters to 2 meters by 2100. So if you put all this together, you can look at constructing the curves as you've seen in the literature. You can go back before we had gauge data, we were using like ice cores and core information, sediment cores. And then gauge data came along around the late 1800s. Then we've kind of switched over to gauges and satellites, and now we're trying to figure out where are we going to be with all these, the best information we have about the climate models. And a lot of that uncertainty has to do with what the emission scenarios will be. So how are we tracking now? If you look at this graph, these are the different scenarios, and you can see the satellite altimetry data. Globally, we've been kind of between the intermediate high and the intermediate low, but it changes based on the region. So for the South Atlantic coast, for instance, we're trending recently we've been trending a little bit higher than that. And of course that interannual variability and things like that, and ENSO and AMO and all those kind of 10-year cyclical things cause it to go up and down, as you know. A brand new report just came out. Some of my NOAA colleagues, a guy named Billy Sweet was the main author on this at COOPS. It's going to feed into the next climate assessment, and they've bumped the upper range up to 2.5 meters by 2100, and you can see they've done these kind of even slices at 0.5 meters. So there's now going to be 6 scenarios, and then kind of easier to look at this way, where these scenarios kind of start to split apart in even increments, but they do associate them with these RCPs to give you a little bit more sense of a probable outcome. If you pick a scenario, you can kind of get an idea of how likely are you to exceed that by a certain date. So this will be fed into the National Climate Assessment and start to be used for planning. And just point this out, and you guys are weather buffs, so you know this stuff, but I like to point out the difference between, a deterministic versus probabilistic versus scenario approach to dealing with, especially for planning. And you look at all those lines and curves, everybody wants to know, well, tell me which curve you want that we should plan to. Picking one curve would just be like a deterministic type approach, where at the end of the 2100, you just give it one number, and you kind of, if you're way above or way below, you could be really wrong. The other option is pick several different scenarios and plan for like worst case scenarios for like critical infrastructure versus lower scenarios for maybe less critical. Or you can kind of look at the probabilistic range, which is the dotted area in the middle there, which is, okay, more likely it's going to be potentially in this range, and you can do it based on kind of exceedance probabilities. So given all that uncertainty, the ranges are pretty far apart by the time you get out to 2100, and even beyond that, they get even farther apart. What's the greatest source of uncertainty there? Well, not only the greenhouse gas emissions, but we don't know what the ice sheets are going to do. We have no prior real data on this. We never studied the ice sheets because they were always been stable. They're hard to get to. They're cold. We have just started. The scientists are. I bet there's a lot more glaciology degrees coming out of our universities now. So they're starting to study these every season, and they're starting to get more and more data on how these ice sheets are going to start to flow, potentially break off, calve off, that kind of thing. So there's a potential there for quite a bit of nonlinearity when it comes to these curves. Luckily, they're not going to be, based on like a quadratic equation. They're going to be all over the place. So, and you can see here that most of the rise so far has been from the ocean warming. And then we also know that sea level is not rising the same rate everywhere. We do have these climatic patterns like Pacific Decadal Oscillation and ENSO that cause the water to pile up sometimes on the Western Pacific. For instance, in this example, that's kind of reversing that trend now, and they're saying water is going to start to pile up a little bit more on the California coast. So this back and forth will happen. So at any given year, we could have a variability in sea level regionally. And obviously land motion plays a big part of that. Again, we've seen 3 feet of sea level rise in Louisiana in the past 100 years. In the Charleston area, we can look at the trend. We've seen about 100, over the last 100 years, about one foot. The Charleston tide gauge has been here since 1921. It's about 86 years of data. We can do a trend line, and I have fairly high confidence that we've seen about 1 foot in the last 100 years. And then we can look at these projections and use some pretty cool tools out there. The Corps of Engineers has a really neat sea level rise calculator, and you can put in, it just uses the quadratic equation you can plot anywhere along here and do a planning horizon, whatever year you want, or whatever scenario, and it gives you your numbers. The city of Charleston's doing exactly that. They looked at some of the NOAA scenarios, some of the Corps scenarios, and they looked at, we want to plan out 50 years, go out and then draw a box and say, okay, we want to be maybe 2.5 feet increase for freeboard and things like that for critical infrastructure, and then only 1.5 for things like parking lots and open spaces and things like that are not as critical. And this would be like a sliding scale. As the science improves, they would update this over time. So I thought it was a pretty neat way of trying to pick a year and a potential scenario for planning. But what's happening on a daily basis here, especially along the East Coast, is that we're starting to meet these critical thresholds a lot more often. This is a great graphic from our co-ops folks showing that, that 1 foot of sea level rise we've seen here on the East Coast. If you had a storm surge back in the 50s, you got 1 more foot of water in the system now. So, and even with high tide events, that water's starting to creep into these, starting to come up into our infrastructure more and more on these tidal events. These are really just simply astronomically driven, a lot of these tide events. Call them perigean tides. People call them spring tides. Sometimes people get confused. They think spring tides only happen during the springtime. It actually means they spring up and down, spring higher. But our biggest tides of the year are in the fall, around October, and in the spring. So we're ready to go into some of our higher tides in the spring, when we have our, in the spring we'll have our new moon, and then in the fall we'll have our full moon, where we get those tide events. And they cause, when we don't have any meteorological forcing going on, we can just have water start coming up into the streets just from the tide at this point. So Weather Service, a lot of the coastal weather forecast offices have these thresholds they use. They base them on our tide gauges, and when you cross over, when it's predicted to go above these thresholds, they'll issue a coastal flood warning. This is the one that happened last October. No, sorry, not last October, 2015. So this was our fourth highest water level ever recorded since 1921 in Charleston. It was 8.6 feet above mean lower low water. It was considered a major flood. We had a lot of issues from that, and there wasn't really much going on other than a really high tide event. That actually wasn't during the heavy rainfall event, although we did have a high tide that day too. So this is what it looks like. If you've ever visited Charleston, this is Wentworth and Lockwood. The water comes up through the storm drain. It's not really connected to the open harbor. It's just coming up through the stormwater infrastructure, and that is a real problem. Because here's a little bit of, if you're not an engineer, stormwater 101, if you look at cross-section of a stormwater system, you have your water enters in on the street level through the storm drains, and then there's an outfall pipe that goes to the harbor or to the water body. At low tide, there's more distance between the two water surfaces, and that creates more gravity fed, and so it causes the water to retreat quicker. If the high tide is filling that, you have a smaller difference, it's going to drain slowly. So a lot of the older cities are based on a gravity-fed system, and there's no other forcing on it. So when tides are high and you get a heavy rainfall event, it causes a lot more flooding problems. So that's why you're seeing cities start to have to put pump out stations and things like that, and floodgates and tide gates. So we've seen an increase in the number of events in Charleston, these flood events where we've gone over the threshold going back to the 20s. It pretty much follows the sea level rise curve, and you can see we've seen a lot more of these events. Plotted out here kind of by decade, you're looking at 11 events. We've had a record events in 2016. We had, I think, 38 events in Charleston, and then if we project that out under some of the scenarios, we're going to start having 180 times a year. So we'll effectively not be able to use certain areas that flood unless we can somehow fix the system. Again, my colleagues at Billy Sweet has done some great work on this. You look at these top 10 U.S. cities. Charleston's one of them. You guys live in some of these cities. 400% increase we've seen since the 50s. Philadelphia, Baltimore, 900% increase. So this is real. This is happening, in our lifetime kind of stuff. So, and if you look out like these tipping points, when are we going to start to see more than 30 days a year? By when? Like under what scenario you can start to say by the 2020s? Unless we start to put some serious money into the infrastructure improvement, we're going to start to not be able to use some of these areas. It's a great app. I don't have an actual slide separately for it, but it's called My Coast. mycoast.org, South Carolina. You can download the app on your phone and go out, and when we have these high tide events, you can take pictures of them and document them, and then it records your geolocation there and the time, and then it looks at the tide gauge and tells you what the tide was and posts it to a website. And South Carolina OCRM maintains that. It's pretty neat. Citizen science. So real quick, I don't want to take up too much more here, but we get a lot of questions about, okay, well, now that we know that sea level is going up, what about hurricanes, storm frequency? And sea level is, I like to say, is an exacerbator of our current problems we already have. We already know we get hurricanes. We just had a real close call with Matthew. Thank God it hit at a low tide. We would have had 6 more feet of water here along the low country. It would have been, and that was only Cat 1. Storm when it made landfall. So it's a little sobering to think what could happen, but the science is kind of fuzzy on if we're going to have more hurricanes and more intense hurricanes. It's the the thinking lately is we may have more intense hurricanes, not necessarily more hurricanes, but because the heat content of the ocean is going to be higher, then there's potentially for stronger storms. And because the depth of water will be warmer at deeper depths, that will be more energy for the hurricane. And so the idea here is if you have your current floodplain 2010 and then you raise sea level, then the floodplain is just going to start moving inland farther and farther. Unless we put things like seawalls in place or start to do retreat, eventually the floodplain is going to start to inundate because we've kind of built up to that line. And this affects a lot of people around the country. Some of the most vulnerable states, obviously Florida, Louisiana, but we're pretty vulnerable here along the East Coast as well. I just showed you a lot of population are vulnerable. Oops. And this is impacting, the economy as well. This is just an example. If you shut down the port of New Orleans, this is a great graphic because it kind of shows like the port of New Orleans as sort of the heart. And if you shut that off, it's connected to all these capillaries and blood vessels. And these are where the goods and services are going from the ports. And if you cut that down, that's going to affect people in Montana eventually. So it's not just a coastal issue, I guess is what I'm getting at. So this is my favorite slide. What are we going to do? Put our heads down, and it's a kind of a overwhelming thing to think about. But we try to show people that places like Charleston, Norfolk, these places are older cities. We're pretty resilient. We've dealt with a lot of stuff. In Charleston, we've had an 1886 earthquake. We didn't have any federal assistance back then. We were able to rebuild. We had Hurricane Hugo. We came back stronger than ever. So, I think we're smart and we can figure this stuff out. We just got to get going on the problem. And one of the first things you want to do, I think we've done that, is identify the problem, figure out what the vulnerabilities are, start to look at options, and then do the cost benefit and actually start sinking some money into the infrastructure, take action. And we've tried to do this in some of our tools. We've kind of to identify the problem. We've done a lot of sea level rise mapping. I encourage you to check out our digital coast. I sent a bunch of links and stuff to Shay. Maybe he can send on to you guys. We have a new beta version that has some of these local scenarios in there. So I invite you to check out that as a scenario tab. Just real quick, this is kind of a cool couple slides I got from the city of Charleston. Laura Cabanis, who's the kind of city engineer. She has this great graphic of an old nautical chart or map of Charleston before we filled in a lot of the areas around, especially on the western side of the peninsula. This is the old shoreline, and you can see where the present-day shoreline is. And well, guess where we get the flooding? So this was all filled in with kind of unconsolidated dirt and even like animal waste and trash, and over where our stadium is, the baseball park, that was all kind of landfill at one point. So that's sinking. And that's where we get some of our worst flooding. And a lot of the coastal cities on the East Coast, we did the same thing. And so where we see the flooding happening are up some of these older inlets and things like that. And the city's actually doing a lot of work now to build these big drainage features, that are huge tunnels that are going to put in the water into a repository underneath about 40 feet down, and then shoot the water out to the harbor using a series of pump systems, and also raising and armoring the seawalls, raising roads. They've already invested about $235 million into this, so they're really starting to take it seriously. Which is, I think, is a good thing. And so they have a sea level rise strategy you guys can check out, and a lot of cities. I know Miami is Miami Beach especially, they're doing a lot of work on this too. I think they've invested about $400 million, and their mayor down there, actually his whole platform he ran on was to fix the flood issues. So I'll leave it at that for questions. I could do a demo if you want of our tool, or I could just open it up for questions and we can go from there. I can I guess I'll unshare here.
Yeah, sure. If you want to do a run of the SLR viewer,
okay,
then
right.
Yeah, absolutely.
Okay, let me do that. Well, let me share again then.
Because I was going to suggest that.
Sure.
It's a really, really neat tool, and it'd be good for you to sort of explain that. to where people could understand. I know. I mean, some of us might know what we're looking at, but others may not.
Yeah. Okay. Is it sharing again?
Yes.
Okay. Great. So if you come to Digital Coast, you can just Google Digital Coast, but I'll just start at the homepage. This is what our homepage looks like. We have access to a lot of different types of data. If you go to data, we have a whole data repository, a lot of elevation data, LiDAR data. LiDAR is kind of high accuracy elevation data. We have a ton of tools, training, things like that. If you go into the tools, actually go back to the homepage, you can see the Sea Level Rise Viewer is one of our most popular tools. We have another one called the Hurricane Tracks. You might have seen historical hurricane tracks. It's a pretty neat tool. You can put in a location and it shows you all the tracks that have passed by there, and then you can select and do all this stuff. But you go to Sea Level Rise Viewer. Here's our homepage. You can launch the viewer. We have a new beta version, so maybe I'll just show you the beta version because it has some of the same functionality. But we have a little splash page here. It kind of gives you data updates. So we are constantly updating this with new data. We just updated the whole East Coast post-Sandy area. We got affected by Hurricane Sandy, and so we have new data in there. When you get it started, you go in, you're able to just type in your address. I'll do Charleston. Or you can type an address or just a city. So you can actually type. There we go. It zooms in. There's Peninsula, and let's zoom out one more. You can see you got these little location spots here, so I can click on that. Pulls up. That's the U.S. Customs House. We have these photo locations, so we know the elevation there from the data, and then we can, with our slider bar here, we start out at mean high or high water, and we're using something called the VData model to do that. It's, we model the tide over about 60 or 80 days, and we have a tide surface. So it does take into account the variability in the tidal surface instead of just interpolating between gauges. And then we can raise the sea level by 1 foot increments. And you can see on the photo, we know the elevation there, so we can kind of estimate when water is going to start to impact the structure. So I always like to point this out because when they built the Customs House back in the early 1900s, they knew what they were doing because that's probably the highest first floor elevation in downtown Charleston. If we'd only built the rest of the structures that way, we would be good. So that it's got that aspect, and you can look at these kind of green areas. I like to show this too because these are the areas where we start to have the nuisance flooding, if you want to call it that. So these are our old shoreline kind of, you can outline them here, especially on the western side of the peninsula. So they're green because they're not connected, but as soon as you get to a certain threshold, they do connect. So these are the areas where it's coming up through, if you imagine passing a plane through the earth, then the water is going to start to show ponding in some areas there. So, and then we can go all the way up to 6 feet. We're in the process of probably mapping even higher than that, given the NOAA tech report. And then the new local scenarios, you just basically click on the closest tide gauge. We're already zoomed in Charleston, so I just click on this, and it gives you the ability to either view by scenario or by year. And this is kind of cool. So you can say, all right, well, if you're Charleston and your planning horizon is, let's say 2050, well, let's just say 2075, if that's the planning horizon, then based on those scenarios I was telling you about, lowest, intermediate, you kind of slide this and say, okay, I want to look at, this is what it might look like by 2075. So you can figure out, or you can say, okay, when are we going to hit 3 feet? All right, under the highest scenario. Well, under the highest scenario, we're going to hit 3 feet at about, I can't see what it says because let me hide this. Year 2058. So you can kind of use it both ways. So you match up your inundation with the years. Same with the scenario if you want to select the higher immediate scenario. And this kind of shows you that the lower scenarios are all close together initially. Let me just do by year. They're all kind of close together. This shows you those curves, but as you go out, it's kind of a different way to visualize those curves kind of spreading apart. We also look at some of the confidence we have in the mapping that we do. So based on the elevation data, you can see, there is some uncertainty because we're so flat, especially in Charleston on the low country. So plus or minus, 1 foot is probably the best we can, even with some of the higher accuracy LiDAR. So we're just kind of showing that. If you're into marsh and ecosystems, we use land cover data. You can pick different marsh accretion rates, and you can pick different years, and then look at what the state of the marsh might be. So are these marshes going to be able to keep up, or are they going to turn into open water? Are they going to run up against a barrier and not be able to migrate? Or are they, depending on the accretion rate, which is the amount of sediment that's going to go on there. And then we have some vulnerability information, but the last one I like to show is this one here, where you've got these red areas. So the weather, we talked about those weather forecast thresholds. Charleston, the threshold is at the gauge is 7 feet mean low or low water, which is about between 2 and 3 feet mean high or high. And we look at how many times we've had this area that in red would flood. 23 times the past 5 years. When we go out to a meter of sea level rise, we basically will flood these areas like every high tide. We have 2 high tides a day, semi-diurnal tide. So, it's just going to be, unless we can either engineer our way out of this or figure out a way to change the land use, we can just identify these areas that are going to, be our first canary in the mines, if you want to call it that. So, and then we link to the same sea level rise trend data. So, anyway, and if you're into GIS and doing your own analysis, the beauty of this is it's a great visual tool, but then you can go right in and to your state. Here's South Carolina, for instance. You can go right and download all of our data. So you can get the DEMs, you can get all the GIS data you want to pull into your GIS and do your analysis, which is really the point of this. So, and we helped out the City of Charleston do a lot of their mapping based on some of this data. So, and we do a lot of that kind of technical assistance for a lot of communities as well. So, and that's about it for the viewer. And we have kind of like
Doug, real quick, I wanted to ask you if you could take a look at the barrier islands, Isle of Palms, Sullivan's Island, locales. There's a lot of homes there, a lot of development, and I'm interested to see what sort of flooding we are going to be seeing there.
Yeah, and if you notice, I'm zooming in here to the Isle of Palms because you mentioned it. A lot of the barrier islands have, if you look at the profile of the elevation across the island, in many cases, the higher elevation is on the front beach because we've got this kind of big dune system that's built up. So when you increase water level, it actually floods from the backside. We do see that with storm surge as well. A lot of times, Outer Banks, for instance, it comes from the backside and then pokes through and sometimes causes new inlets. But you look at 4 or 5 feet, a lot of these barrier islands are they'll be hanging on the edge. Now, this is not taking into account the geomorphic processes. These beaches will migrate. The islands kind of want to roll over as sea level goes up. That's what they're designed to do. Nature wants them to kind of roll over. But if we keep it building seawalls and stuff there, it's going to come up behind basically. So, but this just gives us an idea, and it's kind of neat. If you start looking at it, Sullivan's Island, if you've been out there, these are the old beach ridges. So you have this kind of dune and swale where it collects like fresh water and stuff like that. You can see how the spit has kind of accreted, and then eventually, that gets covered. So a lot of times it floods from the back, and you can see, the homes in here. The viewer doesn't let you zoom all the way in. We have that takes a lot of caching and web service, but you can go download all the data and get that. So, I invite you to go in, and we've got it. It's pretty much for the entire country, except Alaska. We have some data issues in Alaska. Plus, sea level is actually going up, down in a lot of places in Alaska. But so you can, if you guys are on from other states, you can go kind of check it out.
That is fascinating, Doug. Go ahead, Scotty. Do you have a question?
No, this is Ricky. Some of these numbers just are incredible to me. I lived in Hampton Roads for several years. So as you mentioned, Norfolk, Virginia Beach, communities like that are very vulnerable to this type of sea level rise. And looking at some of these maps and stuff, it makes perfect sense. Some of these zones to me, these are the same areas that deal with storm surge flooding on a yearly basis. But just the quite amazing number to me is the flood frequency and how significant that would be. I mean, we go at Sewell's Point from 11 events per year to perhaps 345. I mean, that's a good portion of the year. we could be dealing with flooding. My question goes back to, why is it in meters for the sea level rise and flood frequency while the gauges are in feet? Is that just a unit of measurement thing?
Well, no, that's a good point. And in this new viewer, we actually put in the ability to go from feet to meters. We didn't have that before. We still deal with some communities that, I don't know if you've ever seen Stephen Colbert's little deal about the North Carolina. He said we're never going to be able to understand sea level rise because it's in meters. so that we have that in both. The only reason we did that in flood frequency initially was we actually were talking about in our new version to try to change that, or at least put feet in there as well. So, and I actually want to communicate this in mean higher high water too, because a lot of people don't understand mean lower low.
Sure. That's my other question is there one that's better to look at when it comes to looking at rise, low water versus high?
Well, all they are is datums. You can compute whatever you want to at the gauge. The reason mean lower low is used for a lot of the navigation, the reason we have tide gauges to begin with in this country is because of navigation. So we don't want ships to run aground. So when we do their charting datum, the NOAA nautical charts, the datum there is mean lower low. So you look at they're the lowest of the low tides. If we're at semi-diurnal tide in Charleston or on the East Coast, we have 2 low tides. It looks at the average of the lower of those. So there's likelihood that you're not going to go any lower than that. It's just sort of become the datum that's used that co-ops would report in. Now we have the ability that you can change back and forth. So any of the tidal datums that they compute over that epoch, which is 19 years of the moon cycle, that causes the tides to go up and down over that period, you can use mean higher high. I think mean higher high is better because it's a more of a line that we've kind of, all it takes is 1 or 2 feet above that to start causing some real problems. So, so that's something that I think Hurricane Center and even co-ops, we're going to start seeing most of our products try to make things relative to mean higher high. Because if you just use the topographic datum like NAVD88, that a lot of our flood maps and stuff from FEMA are in, if you started at 0 NAVD88, well, the first 3 or 4 feet is just tidal flooding, so it doesn't flood anything. So if you start at the high point where the water is right up against the edge of the marsh and starts to spill into infrastructure, that's kind of where you want to start. So that's why we're kind of switching our focus to that.
You brought up Charleston and how they're preparing by taking some of these scenarios. Is that what most communities are doing, or is there a scenario that's more popular with some communities, or one that's contested with a lot of communities?
Well, it's a good question. It's not the same in every community, I can tell you that. I think in North Carolina, the state legislature won't let the agencies even plan beyond like a normal extrapolation of some of those curves. And then you have other communities that are looking at the sort of the higher scenario based on their risk tolerance for critical infrastructure. It does vary, and the thing is, there's no magic number. What we're trying to do with that NOAA tech report that just come out is to give you more of an idea of what's going to happen regionally. I don't think I mentioned in that tech report, it takes into account more processes than just vertical land motion and global sea level rise. It's also looking at the density difference that will happen when you melt the ice off of the ice sheets. It's going to change the gravity field, so the water will be displaced differently in the globe. So it actually will cause sea level to go up higher, faster away from the glaciers. It'll actually be lower next to the glaciers because the water is going to be displaced to other parts of the globe, which is kind of a weird thing to think about. And then also the oceanographic currents, slowing of the Gulf Stream and some of these other features, they're taking that into account to give us more realistic values that communities can start to get a handle on. So as we understand the physics more, the science gets better. Like I said, the main thing is what these ice sheets are going to do. That's the real killer in terms of trying to model. I think they're going to get better and better at it now that we've put I think we're starting to put a lot of resources towards that.
Last question for me, and then I'll throw it back to Shay. So let's say we have a big hurricane come along or some type of major erosion event. Do these maps get updated to reflect that?
We try to update areas that are significantly changed. And a good example of that was after Sandy in the Northeast, there was some Sandy supplemental funding that went to USGS and NOAA, and we collected new LiDAR along those from like New York to northern South Carolina, and that data all made it back into this mapping. So we did update. We saw some pretty major morphology changes on some of the beaches in New Jersey, for instance. So yes, we'll try to do that, but a lot of times it takes a couple years to get that data, collected and processed and in. And unfortunately, we can turn around and have another hurricane and change it all. But generally, yeah, we want to try to get the best data in there. In some cases, though, some maps in San Francisco were first done in the 80s with drawn by hand, looking at sea level rise, and with even all the technology and high-res data we have now, they pretty much still show the same thing. So to some degree, you look at the map and you go, okay, this is a problem, no matter what the accuracy is. So,
now, Doug, my question for you is, and you talked about mycoast.org. That is for South Carolina, SCDHEC is a real integral part of that. So state agencies up and down the eastern seaboard, Maryland, Virginia, South Carolina, Georgia, they've all sort of jumped on board with some of the coastal resiliency efforts. And one of the issues that we see is coastal development and stabilization of barrier islands. Talk a little bit about how the coastal resiliency efforts from these state agencies might be helping, or are they getting enough feedback to provide to you in order to help you update whatever data that you have for the coastlines?
Yeah, the state agencies, for instance, DHEC, their main goal or their main mission is to kind of regulate development on the coast. So the idea there is that they monitor erosion rates. They do beach monitoring, including like beach profiles, and they look at the long-term erosion rates, and they will establish these erosion setbacks. And so their job is to protect homeowners from building in areas that are highly erosional and that will potentially have issues. So they'll say, okay, if your building gets destroyed from storm, you can't build back here. It's too dangerous. In inlet areas, that they look at the landwardmost shoreline the past 40 years. So places like Isle of Palms, up by Wild Dunes, that shoreline's going back and forth so much. Comes on a new bar, gets welded on, and it changes so much. So their job is to kind of regulate, we know these are the bad areas to live, don't build there, and try to regulate development. As far as our, NOAA money does pass through to the states for their CZM program. We have certain consistencies we try to hold, as long as they do certain things, they can receive the funding, but we work pretty closely with them on that, and we try to provide them any data they can use. For instance, a lot of the LiDAR data they will use to delineate, for instance, the primary frontal dune, and then use that as a baseline for their erosion mapping and things like that. So, and we try to provide technical assistance too on that, on how to use the data, getting access to the data. And main thing is them not having to pay for it. So if we can provide it, collect it, make sure it's in a standard that the states can use and be comfortable and confident in it, then they're not going to have to spend their money to do it and duplicate. So,
right. So our coastline, I do a lot of wind forecasting for the maritime areas of the coastline, and the nuisance flooding that's occurring many times, especially during perigee and high tides, we see, especially when we have a setup like we have now with northeast winds, northeast wedge setup, that's a driving force. Anything that's a driving force of winds for 24 to 48 or beyond hour period tends to pile water up. Are you able to gauge these type of events? We have like wind roses and data that provide what months we see the northeast winds more. Do you factor in the coastal environment as far as winds go into all of your products?
We don't. And what we're doing with our sea level rise viewer, no, it's more of a static planning tool. But you're probably aware the Weather Service, they do have an extratropical storm surge model they run. They're developing some better technology there, using some more sophisticated models. I know the extratropical storm surge model they run, ET surge, is based on kind of a really coarse slosh model, grid for the whole East Coast, for instance, and they use the GFS to drive the winds on that. And so at any given tide location, you can get a graph showing you what the peaks are likely to be. So for instance, you go to that, I can pull it up if you want right now, but you basically, you can look in there and say, okay, here's the Charleston, here's the astronomical tide prediction. They'll show you what the additional amount of water level will be because of the setup. And then for storm surge, that's something that the Hurricane Center will run. They have a probabilistic version of slosh called P-surge, and they vary the track and intensity, all these different tracks and intensity runs, and do an ensemble basically, and then give you an exceedance probability. So, and then they take that 10% of the exceedance and map that and show you the potential depths. So they're doing that during Matthew, and turned out to be pretty accurate. Now, 10% exceedance is going to be a kind of an overestimate potentially, but that's the idea. Is they want to be conservative with that too. So, so what you're getting at is you get into the sort of the forecasting and modeling. That becomes more of an operational thing where you have to have you're bringing in the real time data, winds, and all that to do it, and that's what they try to do. So, and that's where your data comes in handy. Couldn't do it without it, right?
Yeah, we're working hard on our mesonet, trying to expand our mesonet to capture these events so we can get a better idea of it. Ricky, did you have one more? Or we probably need to sweep it by the panel because we're getting a little bit after the 9 o'clock hour.
Yeah, if anyone else on the panel has a question, feel free to jump in now. Otherwise, I'm going to kind of end with our typical questions. No?
Go for it.
All right. Well, in that case, Doug, what's a good path for someone who's still interested in the science, maybe just getting into college, to take if they're interested in doing some research on sea level rise or something like that in the future? Is it GIS? What's the path they should look into?
It's a good question. I'm not sure my path is the most direct. You do, though, if you're a geology major, you do study a lot of paleo sea level rise kind of thing. So you really do understand sea level rise cycles. And of course, you look at it in the rocks and stuff like that. So understanding the curves and what drives it. So you do learn that. But, if you do go into GIS, especially data collection and elevation data, that's going to be, I think, a growing field. Doing the remote sensing science, like the aerial photography, satellite imagery, and LiDAR technology is getting like crazy accurate, and it's just more and more data. And if anything that goes along with that, you're a database guy, and you can learn how to handle all these data sets and process, and there's a path there. Obviously, meteorology, but I would say if you want to study on the ocean side, meteorology and oceanography, maybe an oceanography degree is maybe a little bit more valuable, but things like storm surge, total water level is a multidisciplinary thing. That's why we haven't done it so well in the past. You got your hydrology guys telling you what the rainfall is going to be. You got your surge guys telling you what surge is going to be. You got your engineers worried about wave run up, and you have to have all of that to get the final answer right. And we've always had these silos of people. I know this answer, I know this answer, and they've never been kind of put together. We're trying to go that way in NOAA now to sort of couple these models together. So having an understanding of the whole system, I think, is going to be valuable, because that's kind of valuable in the future. That's where we're going with it. So,
all right.
So get a degree in everything now. I would say, though, there's a lot of degrees out there now that are these sort of like marine science, more general policy. That's fine if you want to do some of the more policy-related jobs, but I still feel that really getting a good technical degree in either meteorology or oceanography, something like that, a hard science is going to be more valuable to you if you stick with that type of career.
How much do you guys employ people outside the disciplines, people who have experience in a field but maybe don't have a specific degree in that field?
We do it all the time. We've got folks here that in our office that have just geography degrees, and they know how to do the GIS, and then we teach them the process stuff, the hazards. Then you have content experts that don't know a thing about GIS, and they can. We end up working on teams, and so it's good to have people that know different parts, and not one person has to know it all, which is the great thing about that. So we do it all the time. Some of our best employees we have now came as interns to us from like the College of Charleston geology department. We've hired several that have been really, I don't know if you guys know Dr. Leslie Sauter, but she's sent us several students, top notch. And I think they just come eager and they're willing to learn, and they're young. They just run circles around me on the technology. Like
That's awesome.
I can't keep up.
So many people get degrees in meteorology, but then they change what they're really interested in as they go, a few years past having a degree or graduating. So it's great to hear that. So.
Yeah, you're right, Ricky. I mean, if you're doing meteorology on the coast, you're almost forced into a little bit of oceanography and hydrology all together. You have to sort of blend it all and then think about everything as a whole.
Yep, definitely do. So.
All right, guys. Well, we appreciate you coming on tonight, Doug. I don't know if you have any social media or maybe an email address or something. If any of our followers would want to get in touch with you or maybe learn a bit more about this, how could they do that?
I have my own personal Facebook page, but you can just get in touch with me by email. It's pretty easy. It's just Doug, DOUG.Marcy, MARCY, at NOAA.gov.
All right. Well, we appreciate you coming on.
Now, I'm not going to answer political questions. I'll tell you that. So.
We appreciate you coming on tonight, Doug, and a wonderful presentation. And thanks for all the work that you guys do. I know this is a very important project, and we appreciate the work you guys put into it.
Well, thank you. And thanks to Shay for inviting me.
Absolutely, Doug. Anytime. We'd love to have you back on, too, especially as we get into the hurricane season and any other updates that you have. We'd love to have you just come on and do the show again. I mean, even this is fascinating information. It's really good. I learned a lot from you tonight. So thank you.
Great. Yeah, we'll do.
All right. Well, we appreciate Doug coming on. And if you're listening on the rebroadcast, the podcast, anything like that, there was Doug's email address if you have any questions concerning sea level rise. So next week for Carolina Weather Group, we kind of round out the National Weather Podcast Month. Stormfront Freaks, a fellow weather podcast, will be joining us next Wednesday night at 8 p.m. and it's going to kind of just be a fun show. No set topic to talk about. They're going to talk a little bit about their podcast, and we'll talk a little bit about ours, and kind of come together and just have a general discussion about weather. So we're looking forward to having the Stormfront Freaks with us next week as we round out the National Weather Podcast Month. So for everyone at the Carolina Weather Group, we hope you have a great rest of the week. Stay safe out there, and we look forward to seeing you next Wednesday night.